Hey guys, let's do our intro to AP Physics. And to start off AP Physics, we're going to learn some calculus. So first thing we're going to do is we're going to talk about the power rule, which is your quick and dirty method you'll use all the time to solve differential calculus problems, taking derivatives. A derivative is how you go. The whole point of differential calculus, which is like half of calculus, is how to go from an original function to a function that's that original function's rate of change. So how quickly it's changing with respect to one variable. And that sounds very terrible, which I wrote here. But you do it all the time. So if you want to know the rate of change of displacement with respect to time, that's velocity. We do that all the time. We find out how quickly displacement is changing with respect to time. And so the derivative of displacement with respect to time is velocity. Notice I use the variable x because otherwise it's dd over dt, and that just doesn't look right. By the way, this means you're taking the derivative with respect to time. So d whatever, d what you're taking the derivative with respect to. Anyway, so derivative of displacement with respect to time is velocity. We've done this. We just find the slope. Usually we've got easy situations in physics 11 and 12. We got some sort of slope where we just find the slope, like a straight line. So it would translate to this graph. We've got this function and it translates to this function. As another example, rate of change of velocity with respect to time is acceleration. So if we wanted to go from the original function velocity to the derivative function, the rate of change function, we'd take the derivative. And so if we take the derivative with respect to time of velocity, we get acceleration. Now, you're all like, why do I need to know this? I can easily find the slope. But it's a lot harder if you've got a goofy graph like this. Like this is probably a polynomial to the fourth power here. And that's not so easy to find some function that's the slope of it at one time. But with calculus, we're going to be easily able to do this. So if we've got some sort of crazy acceleration function causing some crazy velocity function, we can solve for it, and it's not that hard. So if your velocity function looks like this, your acceleration function will look like this. Notice all I did to come up with this is, hey, we got a pretty high initial slope that's getting less and less. It's crossing through zero slope here, so it's crossing the zero axis. At this point, it kind of like inflects from the slope getting less and less to getting more and more. So that's kind of the bottom right here. And then it goes back through zero, and then it's getting more and more positive until at some point here it stops getting a more and more positive slope and starts becoming more and more negative. That corresponds to this point, and then it just keeps getting more and more negative. Crosses zero at this point, and then keeps getting more and more negative. But we're going to be able to do that with math, and it'll be much easier. Anyway, here's another example. Rate of change of momentum with respect to time is net force. If you had your momentum time graph, we'd find the slope and it would be net force. You might not know that as much because we do it a little less. Anyway, so all I want you to do this video is I'm going to give you a pile of examples, and I want you to figure out the power rule for yourself, because it's really not that bad. And I bet you can figure it out. And if you can't, just watch the next video. I'm using t to the 1 for t because that is might be useful, might be relevant to realize that if you've got some variable and it has no noticeable exponent, secretly it's to the exponent 1. So here's a bunch of polynomials, which is all we're going to care about for the first bit. All right, so derivative of t squared with respect to time is 2t to the 1. The derivative of 3t squared with respect to time is 6t. Derivative of t cubed is 3t squared. Derivative of 4t cubed is 12t squared. How do these guys relate to each other? How did that 4 affect affect your derivative? Derivative of t to the 4th power is 4t to the 3rd power. Derivative of 2t to the 4th power is 8t to the 3rd power. And the derivative of t to the 1st power is just 1 times t to the 0th power, which might give you some idea of, hopefully you're figuring out the pattern here, which is just 1. So, and if it's 5t to the 1, this should show you the pattern, but keep in mind t to the 0, anything to the 0th power is just 1, so that's the same as 5. One thing I forgot to write down, which I'll do just now, if I take the derivative of something, let's say 6t to the 0, which again is just a fancy way of writing 6, that is just 0. So any derivative of a constant term is going to be 0, which maybe you can figure out by the rule. Anyway, see if you can figure it out. Good luck.